all these. Let us see what the in the geophysical aspect we have two important: the seismic, gravity, and many things. Just Dr. Chobe has described nicely. I'm not going over there. I will only give some seismic data. The second part is the chemical structure. What is the thermal structure of the Bundelkhand crust? So we know these are the major rocks: rhyolite, rhyodacite, grey granite, biotite granite, pink granite, gneiss, potassic granites, sodic gneissic TTGs, and their values. Density, you can see the density, you can see the thermal TH values, you can see their uranium value, and you can see their potassium, and you can see what is interesting thing. In while biotite it is a it is 5.5, while the grey granite having the heat production low. The grey granite affected by the east-west fabrics, while these two, biotite and pink, were not been affected. This should also keep in your mind. And rhyolite and rhyodacite, they also having the low heat flow values. If you see the, oh yeah, if you see, the heat flow is 35 to 55. Average heat flow is 39. In the central plot, heat flow is high. In the southern part is low, and northern part is different. On the basis of the heat flow and the geophysical structure, we are now in position to say that the Bundelkhand Craton is also a like a Singhbhum, Eastern Dharwar, Western Dharwar, and Bastar. It is a craton. It is a category of the craton, having a thick lithosphere and other things, while others are either the mobile belt or the basins. You see, Julian in 2009, given the she has pointed Moho at a depth of 37.5, and Mangalik has correlated this value with our heat flow data and the thermal data, that the Bundelkhand is also like other craton of the world. And you can see the layer structure within the Bundelkhand Craton. Yeah, this is the model. In both, we are getting the anomalies near to the Bundelkhand tectonic zone, either in the thermal structure model or in the seismic profile model. We are getting some discontinuity is there. And before my lecture, it was properly discussed by Dr. Chobe that their east-west trending Bundelkhand tectonic zone is an important tectonic zone in the Craton, where northern plaque has the different story than the southern part. If it is so, the potassic granite are toward the southern part, while the sodic granites are in the northern part, and in between these two we have the TTG rocks. TTG rocks enclaves are found in the sodic granite, in the biotite granite and the grey granites, but TTG enclaves are not found in the pink granite. And you can see the heat production HP data across this. Again, the next important part is the quartz reefs. Quartz reefs in linear fabrics, and point shown is like a pyrophyllite diaspore deposit in the Bundelkhand. They are mainly associated with the quartz, not found away from the quartz reefs. Beautiful quartz reef. Quartz reefs constitute a most spectral feature of the Bundelkhand. Persist a regular or certain interval, composes variety of variable size of the quartz veins, mylonite, formation of hydrothermal deposit, mainly the hydrous minerals. These hydrous minerals, not only the pyrophyllite and diaspore, but they, which has not yet been discussed. The quartz reefs are 100 to 100 kilometer in the length, 300 to 400 meter thick, a tectonic zone, example of intracratonic siliceous magmatic emplacement in the northeast southwest shear system. We have already fully described in one paper the northeast southwest shear system, how it has formed. You can see the pyrophyllite diaspore in the Bundelkhand. The people are only working for the pyrophyllite and diaspore. Nobody is interested to see what are the other minerals. In the last month, I visited more than 500 mines, different part of the Bundelkhand, and I noticed other minerals are there. Question come, how and when the quartz reefs were formed? What are the technical processes at the depth of the formation? How much temperature required for these reefs? And what is the source for the hydrothermal solution? This is important for the quartz reef now. The northeast south trend crustal shears is giant shears along which this has developed. When and how the quartz reef have formed? When we do not punish it. When it has formed, only one data is available. That is 2300 by the Pati, and some other data is also available, but the values are coming 1600 to 1700 million year. That is not correct, because quartz reef never crossed the Bijawar, never crossed the Vindhyans. That is only confined into the Bundelkhand Craton. And the quartz reefs are, quartz reefs are traversed by the northeast, northwest, southeast mafic dikes. Another important thing, these quartz reefs cut across the east-west tending fabric. East-west tending fabrics, we are thinking that is a subduction. So these were developed during the granite or after the granite, we have to think. Our data should be, our concept should be clear. Whether they have formed of the granite or different episode. We have to think with open mind. Tectonic setting, they are developed in the shear system, not away from that. In the shear system, the extension regimes were there, but they are across the Bundelkhand tectonic zone, associated with the crustal deformation and fluid pathway. Depth of temperature, depth 5 to 25, and temperature ranges from 250 to 500 degrees Celsius. The fluid sources may be magmatic fluid, metamorphic dehydration fluid, or the meteoritic water mixing by some other things. No study has been done. We have to do it. And then we have to go for the integrated model, heat flow, the enhanced geothermal system, and the quartz reef. Regional thermal regime. Today in the Bundelkhand, we have the heat flow 30 to 55, average is 39. In continental setting, thermal anomalies, but we have observed the local heat pocket existing in the Bundelkhand. That is important. In the biotite granite, we have the different kind of the heat production. In the pink granite, we have the different heat production, or even within that, we have the heat production. This indicates the localized heat production existing in the Bundelkhand. Northeast southwest trending shear zone and fabric, both together controlling the enhanced permeability, pathway to deep fluid circulation, act as a natural conduit for transfer. Third point is the temperature and fluid system. Deep heating which cause the siliceous melt, hydrothermal fluids. High temperature more than 600, it is easy to come 600 degree after the granite emplacement. The melt and fluid generated 5 to 10 kilometer, moderate temperature 250 to 400, quartz reef precipitation, and low to moderate we have 200 to 300, where the alteration of the minerals and lot of pyrophyllite and diaspora. Natural enhanced geothermal system was existing in the Bundelkhand. Along the shear zone, natural enhanced geothermal system has developed. And this is responsible for the generation of the quartz reefs, and this can also be further used in the different work. The fracture controlled fluid circulation, heat extraction, if it has developed, then heat extraction from the crust has taken along this shear zone. It has enhanced the system. Sustain the hydrothermal convection cells. No, it is a geological preconditions, EGS system. Mineralization, surrounding alteration halos, host, develop the pyrophyllite and diaspore in many deposits. You can see pyrophyllite diaspore developed at the latest stage, quartz veins are there. If we integrate the first one, geothermal gradient contrast, only we have to enhance 35 to 30 degrees Celsius due to the heat flow. Then middle crust, such temperature will be there. In the shallower crust, we have the 200 to 300 degrees Celsius and 2 to 30 kilometer depth is required. This is the value found in the different variety of the granite. If this system was existing, there is a chances of red color minerals to be enhanced in the quartz reef. We have to relook the quartz reef again. Thank you, sir.
Any question? Yeah.
Sir, in one slide, you have shown there was a alkaline magmatic. So, are we expecting any alkaline complex or carbonatite deposit?
Carbonatite is there, cyanide is also there, but Re value is extremely low. It is published work. And apart from that, we have also noted 3-4 carbonatite within the greenstone. They are also extremely low,
not very much.
Extremely low.
Right. And
from the Khazarha, it's already published the lithos. Extremely low Re carbonatite from Bundelkhand.
Because in many craton, we are getting this carbonatite as well as this.
Sir, we do not know why we are getting the low Re value in the carbonatite of Bundelkhand. We do not know. I have the analysis of 5-6 carbonatite bodies of the Bundelkhand, and every time getting extremely low Re values.
Sir, one thing.
I am also looking why it is so happening in the Bundelkhand crust.
This is mysterious.
Yeah,
this
is a mystery. We have to solve it.
We have to crack. Sir, another thing we have shown one slide regarding quartz reef. There was a dehydration flutes.
Yeah,
So are we getting tourmaline in that area?
tourmaline was not found in the granite. So for the dehydration, when it has gone below the 18-kilometer depth, the biotite start to melt. That is a dehydration, and from there the water has come.
Okay.
Sir, just for my understanding, sir, how you have collected this heat flow data, sir?
Myself and the NGRI group, Labanira, Sukanta, and all, we are working together since 2012 from the board data. And board data means with the help of the Central Groundwater Board, we are so much thankful that they have provided me facilities to restudy, to revisit the boards. And the material that has come near to the bore and surrounding rocks, all things we are doing right from 2012-13 to till date. And all these things has been done in the NGRI, and I am also associated with them.
One more question, sir. You have shown that that this DTG, sir, what is the potash content in that?
In which,
Sir, gray granites you have shown. Sir, if I'm not wrong, it is more than 2 to 3 something.
yeah, around.
But don't you think it should be low, sir?
Na2O is high, K2O is low. Sodium rich and potassium poor. That is the gray granite.
In one slide, you have in photograph you have shown there was a metasomatin. In one slide, pink granites and gray granite was there. If there is a metasomatin, either it is a potash metasomatin or sodium metasomatin.
K2O metasomatism. Because pink color is coming.
Yeah. So if there
And
is
this pink is coming in the gray granite along the fracture and shear, and also in the biotite granite also.
so if there is
I can show you. Because this is very important for everyone. Yes, last last. See here, two things. If I collect a sample below that, it is also a pink.
pink, okay.
In the center part, it is the pink. And last one also. But you see, there is some structure. There is something. We have to very carefully look at. You see here. This is nearby that pink, brownish color pink granite. You can see it was a gray granite which is converting into the pink. Thank you, sir.
Thank you, sir.
Sir, in the south of
This
Khetri,
is the K2O metasomatism.
so these granites are potential for the RE. These granites are potential for the RE bearing minerals.
We have to see it, sir.
Because in the south of Khetri, if you see, there are a lot of pink granites and metasomatin in there.
In the okay.
So in that area, a lot of potential for RE is there. AMD is also working in that area.
Copper and molybdenum both are there in a pink, in a medium grain pink granite is in a granites. In the coarse grain pink granite, molybdenum and copper values are coming higher. And when there is some small patches are there, you can see the clots of the molybdenite there. and class of the sulfide there. Okay. Second point, when I was doing groundwater sampling in the entire region, I noted very high value of the copper in certain places of the groundwater. My grid sampling was 2 square kilometer one. And in that, I found the circle. I have the data. I can say that this area is good for the copper within the alkali granite.
So we have one more question. So from him.
आवाज नहीं आ रही है यार, बता दो.
Please provide mic.
Sir, actually, my question is regarding the source of fluid. Sir, on what basis you have such this meteoritic fluid?
I have never said. I said we have to generate the data for the source of the fluid. No data is available. Whether it is a meteoritic, whether it is a dehydrated material coming from the mantle, nothing is known. We have to work
You just suggested
in the quartz
the
reef.
three,
In the quartz reef, we have to work out for the not only the just fluid composition, but we have to see the fluid isotopic data.
Yes, sir.
This is the future work.
Okay, thank you.
Okay.
Yes.
More question?
Sir.
For the excellent contribution.
Thank you, sir.
Sir, one query I have in my mind. What is the potentiality of the sites where we get the intersection of quartz reef as well dolomite dike?
Pardon, sir?
Potentiality of the sites or locales where we get the intersection of quartz reef and dolomite dike. Mineral potential.
Sir. Personally, at 3 locations, I found that the mafic dikes were cutting passes through the quartz reef. Okay, they are both very small, but 7, 8 places I noted a special kind of the fine grained pink granite which was received into the quartz reef in the adjoining area, or sometimes it is cut across the quartz reef. I tell you, people have to work it with open mind. There are the granites, and at one place, I sent the sample to Australia, and I found the age 800 to 900 million year for a granite. I afraid not to show any person. But such young granites are also in the Bundelkhand.
Sir,
I can share after the.
this was an
Yeah.
excellent presentation on
Thank you, sir.
quartz reef, its temperature, its model, particularly the model you have shown. The question is, we have, if we see the geochronological data of the basic dike, there are a huge time gap, different sets. How these particularly 3 different edges has come for the basic dikes. How these 3 are correlatable with the basic activities in the surrounding areas. One thing, because in the first of presentation by Mandal sir, there was also 1100 million years one age has come. One age has come 22 million years, 1800 million years. Then how such a long period of time gap, different time basic activities has been
That is coming.
and
We have to.
because 1100 million years is related with the kimberlite activity in Majgama.
Sir,
Related with
You know, sir.
1800 is something different. Quartz reef cut by the basic dike is another event around 1400.
For the kimberlite, we have to rethink.
Yeah.
I'm
And
not going to give
moreover-
any lecture for
more-
that. That is
mo-
my separate
yeah.
issue.
Moreover, this Mahoba dike is also very, very young.
Yeah,
Very,
very
very
young,
young,
very young.
this dike. Then
It
with-
means, sir,
with what-
sir, it means the Bundelkhand Craton, what we were thinking, it become stable after the Vindhyan basin. It is not true because we are getting the granite, we are
Sir-
getting the ultra,
Sir,
we are getting
my
the
last question is something
the
different.
basics.
Something different.
Yeah.
Because Mahoba dike is considered to be the extension of BTZ, isn't it? Isn't it
reactivated.
reactivated?
Re-
Reactivated at the time of 1100.
At any time, reactivation maybe
Then,
we have to
then
see it
what
in time
tectonic
frame.
event, global tectonic event, can be correlated with this
Yeah,
reactivation?
we can correlate, sir. We can correlate. Firstly, we have to say better safe. It is a reactivated activities. So reactivation along the east-west,
Yes.
reactivation along the north-south, or any. The
Sir,
Bundelkhand
what-
Craton was not
Yeah,
stable.
one of my paper is on the reactivation of fractures
Yeah.
only. But this event is something different.
Yeah. Because we have to go for its genesis.
Just below, before the camos,
Yeah,
or even coeval with the camos.
I agree, sir.
Thank you, sir, for a very
I
nice
will agree with you,
deliberations.
sir. Yeah, thank you.
Sir,
मिनरलाइजेशन कहाँ मिलेगी सदर्न साइड में ज्यादा चांस है north
नदर सदन में कुछ नहीं है जो भी है पिंक लाइन Yeah, in the southern part. Yeah, I agree, sir. Yeah, that has also come up. Secondary mineralization, it has created a porosity in the system. And
Sir.
along that become a host for all these materials.
Sir, there are so many quartz reef
Yeah.
in this terrain.
They are
So-
occurring systematic intervals, sir.
Is there any compositional or mineralogical differences in this?
I am looking for that because I collected more than 250 pyrophyllite diaspore minerals, and in the field I found the different color, different set, and small grains are also there. What is those grains? I do not know. Last month I collected the samples. So at this stage, I cannot say, but as per the mechanism of this quartz reef, the surrounding material has to come up. If the quartz reef in the gray granite field, then very less amount of all the things will be there. And if the quartz reefs having a higher values of, like quartz reef which passes from the ultra potassic rocks, quartz reef passes from the high zone of the tin tungsten mineralization. So there is a good chances getting the hydrothermal mineralization.
Another thing is that within the quartz reef,
Yeah.
what is the nature of quartz to quartz contacts?
Is different, sir. It is a the injection was going on and deformation was also going on.
Means
Okay.
there is a possibility of stretch,
Stretching is there.
maybe
lot
a possibility of
yeah,
it stretching.
stretching.
So these are directly related to shearing. Shearing,
Shearing is there, sir. Shearing and extension both, and rotation is right.
rotation and shearing.
All the
And
three are there.
as your PPT shows, its depth is about 5 to 15 kilometer.
Maybe
Kilometer.
we have to generate a fluid. We have to generate some liquid material.
Uh-huh.
So we have to cut the geothermal gradient with the melting temperature of the rock.
So is there any possibility of some RED mineral associated with this quartz reef?
Yes, not in reef, maybe along with this quartz solution, but nearby to that, lot of clay materials are there, phyllosilicate
Yes.
minerals are there.
So-
In the phyllosilicate, there is a good possibility of the thorium, uranium, lithium, and many others are in.
So the pyroflite which you have just mentioned, that may be the another carrier of such minerals.
Yeah. Yeah,
Right.
exactly.
Thank you, sir. Thank
Thank
you.
you. Thank you so much, sir. Thank you, sir, for your excellent and informative lecture. We are deeply appreciative for the significant contribution you have made to this workshop, sir. Thank you so much, sir. And it is requested to all the participants, those who have joined virtually, please leave your message, leave your queries in the chat box. We'll request our speakers to resolve your queries, if any. So now, as we conclude this morning's technical session, I'm pleased to announce a lunch break. Please reassemble for the afternoon technical session at 3 p.m. Thank you so much.
बंद कर हेलो हेलो हेलो
आवाज आ रही
सर आपको आवाज आई? आपका वीडियो सर ऑफ है शायद। अच्छा
स्क्रीन शेयर हो रही ना।
स्क्रीन शेयर है, ठीक है कोई बात, तब भी वो हम इस पे ले आएंगे ना, मूव टू स्टेज मैं करता हूँ। कैमरा ऑन रखें बस। कहाँ पे है ये, इसको बंद कर। चलेगा।
बस
हाय हाय।
Hello.
Hello. Namaskar, Govind sir. Namaskar. How are you? Mr. Dora. Sir, sir. Thank you, sir. Interview. Sir, thank you, sir. Okay, please carry on. The number is there. Actually, sir, JNU marketing भी है कल और परसों 2 दिन लेकर करने का जरूरत है वो उनसे पूरा प्रोग्राम चल रहा है एक्चुअली राइट है तो अगर ऑनलाइन में कोई बनाए टाइम में डिस्कस करेंगे Doradi, welcome from here.
So a very good afternoon to you all. Now we have next technical session which will be held virtually. So I would like to introduce our guest speaker. It's my immense pleasure to welcome Professor S.P. Mohanty. Oh, sorry. So, I'm so sorry. So I would like to introduce Professor M.L. Dora, currently professor at School of Environmental Sciences, JNU, New Delhi, since December 23rd, 2024. He's a renowned geologist and former Deputy Director General at GSI. With expertise in mineral exploration, ore genesis, and critical minerals for renewable energy, he has authored over 80 publications in economic geology. His accolades include the National Geoscience Award 2014 from the Honorable President of India, the Indian Society of Applied Geochemistry Award 2019, VSSR Medal, the Sri Sitaram Rungta Memorial Award 2022 from SGAAT Bhubaneswar, and topping his MSc Geology class in 1995 at Kalikot Autonomous College, Behrampur University. Joining GSI Nagpur in 2000 as geologist, Group A, Ministry of Mines, he earned a PhD in economic geology under Professor Kriti Kumar Randiv. Accumulating 22 years of field experience in copper, lead, zinc, gold, nickel, copper, Ag, BITE, graphite, vanadium, titanium, barium. Prior to GNU, he served as OSD Ministry of Mines and represented India abroad in Australia in 2012, South Africa in 2016, Canada in 2018, and UK in 2023, and Busan, South Korea in 2024. As Associate Editor of Gondwana Research, Elsevier, since February 5th, 2025, he holds life fellow memberships in Geological Survey of India in 2023. So I would like to invite Professor M.L. Dora, sir, for his lecture, sir. So over to you, sir.
Thank you, madam. Can I read it?
Yes, sir.
Respected DGGSI, ADGPSS, Dakshi sir, ADG HOD NR, Rajendra Kumar sir, DDG Unit UP Gaur sir, and dignitary, my senior, serving and retired GSI, and all dear participants who are joining in person as well as online from different places of the country. It is a very good afternoon to one and all. First of all, I extend my sincere heartfelt thanks to Gaur sir and Hemant Kumar and Rajendra Kumar sir for giving this opportunity for sharing my experience. Though I have not worked in Bundelkhand Craton, but I will share whatever I know about the metropolitan part. I am extremely sorry and apologize not present in person due to my prior commitment as a convener in hosting one-day workshop at ANU in connection with application leadership tomorrow and day after tomorrow. I honestly feel this work is very important in connection with metallurgy of Bundelkhand Craton. Really, truly, it is a enigma as compared to other core patterns of our country. Today we discuss through middle system approach, how I can give some of my experience with whatever I did earlier. With that. So during this talk, I will deal in three parts. One is how middle system, why it is important, and the successful discovery of deep seated pencil deposits in a Western Craton, similar type of these massive quartz veins, giant quartz veins, what we are seeing in Bundelkhand. The third part, how this mineral system approach can help in Bundelkhand Craton. This diagram, as we all know, the gradual depletion of surface and soluble mineral resources has driven the mineral exploration agency toward the deeper level. So, the future mineral exploration involves searching of constant deposit in a greenfield area or a greater risk in a brownfield area. There is only two scopes left, and all knowing groups have been discovered. This figure clearly shows how the discovery rate of this 125 years history since 1900 to till date. These are the deposits were discovered different times, but they clustered at particular time period. Why? How it shows? Maximum deposits are clustered in and around 60 because clay fertilization is introduced, followed by good number of geophysical techniques are introduced. After the Second World War, most technologies were introduced here in the mineral sectors. Except from gold, which was always attractive in the first diagram. Gold was in 1940 during World War because of maybe because of price of gold boom or gold rush, we get so many. Otherwise, if we all three clusters, they are more in the 2009. Why it is so? After that, again decline starts. Because mineral system concept was introduced in way back 1994 by Weibel in Australia. Same time, 1992, IFC concept was also introduced in Australia. These two, though there is no proper literature, no connectivity with mineral system with IOCG or Olympic dam, but Olympic dam has great influence to conceive the idea of mineral system. Nothing above, they taken the clue from the successful story of the petroleum discovery, that is the source, sink, the deposition, the craft like that. The same, they the mineral system of this. Why it was required? We everyone knows science has advanced, tools and technology has developed, but geology uncertainty remains as it is. Because our processes are linear, they are complex, mineralization is rare, very localized concentrated. If everywhere, if all candidates combinations of many extractors will work together, then mineralization will take place. Otherwise, it's very difficult to get mineralized everywhere. The decline of discovery rate after 2009 is not due to that deposits were not discovered. Not that Earth has totally drained out of the mineral system, not like that. But whatever surface deposits were there, they were discovered. But the remaining concealed deposits are there, maybe because of government policy, or a price, or junior mining's involvement and their interests, their profits. There are so many factors. As today, we are everyone is rushing after petroleum, so we are everyone has is grounded in the ground to discover things. That was how these two graphs are showing. 2009 there was a peak because of the down diagram which is explaining. China is dominated in this that showing the red color, otherwise the pink color in Eastern Europe and in Russia. Federation Soviet Union as to why. These are the things one should know that why inlet system approach was required and why it was introduced in 1994 by Weber. Because they studied a lot of things in Australia, great Ingrid Craton or Goalite Craton, many granite systems they experimented fertile versus infertile. And by taking the clue from the petroleum discovery and taking the clue from the Olympic dam how it was discovered. Olympic dam was not discovered by accidentally. It was discovered based on persistence hypothesis. They initially thought it is a porphyry deposit. They went with porphyry deposit model. They think then they thought it is a sedimentary type deposit because a thick pile of sediments are around 350 meters. And that also then say that part of food attempt they succeed. One of the best, one of the biggest ever deposited discovered by any service in that. Because it is a polymetallic, and that success story has influenced many of our geologists across the globe. Why the mineral system is important, whether it is a barren pattern or it is a settled pattern. Because mineral system don't deal with any one product or any one commodity. It deals with the process. How the processes are involved. What is the source? How the source has influenced by tectonic process. Then how the fluid and metal generated, if generated, where they went, how they migrated, how they transported, where they trapped, what were the physiochemical conditions prevent that to trap these elements or metals. Then after the post-equational, they are not whether many of times they that many of times sometimes they preserve. These are all things with the mineral system, which is the mineral system contains the five ingredient things: source, both deal with metal and fluids. Many of the places we get fluids, but we don't get metal. Drivers, the geodynamic tectonic setting is the one of important, whether subduction trigger or it is a collisional settings trigger for generating the fluid as well as metal or the heat. And the pathways. Pathway is one of the most important way. That is where the fluid will migrate will come from environment, lower crust to upper crust, or even so this year when it will come above the little adapter transition, then only it will distribute along the other structures during pressure drops, then only the mineralization precipitation slows. The trap is also one of the important aspects. Then the primary preservation should be there, otherwise you won't get any mineralization. During the trapping time, many a times it is concealed. You may not get the good. But when sink is a mode, it will deal in the form of ultrasound footprint. Only in a geologist, if you are lucky enough, you will get surface evidence of mineralization in form whenever you will break the rocks. But every time it's not necessary. But if you get ultrasound, they are the footprints. From the ultrasound, you should consider the ideas. If you get the ultrasound, then what could be the possible mineral system? Then permutation combination, because I told Earth is not a linear, Earth is not controlled by linear process, it is controlled by heterogeneous. So there will be a lot of permutation combination, there will be a lot of overlapping systems of processes working. So the mineral system is developed to overcome the traditional way of mineral exploration, which only deal with a particular commodity in a particular place. Generally, we follow the world market because what idea people then 100 or 200 years ago, or even more than 200, 500 years ago, they were built out, and only now left with records and all the world working artifacts, all these things. But something was concept there might, but today, even here, technology has come, but we are still following, and it is giving the guidelines. That is the best for a ground to get process. But when everything is conceived or agreed to, then it comes what type of technology is required to discover the beautiful deposits. Mineral system explores systems help in exploration in covered area, that is in greenfield, and the helps in understanding the deep seated deposits in the ground field. These are the two ingredients. Mineral system approach follow the 2D, 3D, 4D, 5D. I will discuss in subsequent slide what is this 2D, 4D, 4D, and 5D. Okay. The mineral system was introduced after 2009 to address the decline discovery rates. Because discovery rates was declined, the cost was raised, but mineral industry has to survive. So it was one of the research group they developed in Adelaide in Australia. They because of this Olympic dam story, it is influenced many. So this is about mineral system. Once you know the mineral systems, 5 ingredients, which there apart from this 5 ingredients, there are so many other sub-factors which play very important roles. So the temperature, pressure, fluid chemistry, fluid mixing, fluid boiling, fluid of interaction is one of the most aspects which we see in the form of ultrasound. And the salinity, that also plays very important role. And the more important is redox change of oxidation to reduction, vice versa, and the pH condition, acid condition, as well as the alkaline condition, which metal transport, where it will precipitate, everything it matters. These fundamental things are very much required. Finally, the structural pathway, otherwise how the fluid will come, how the metal will transport. And moreover, it requires a long system, hydrothermal system. Whether it is a magnetic system, a long, prolonged magnetic system is required to precipitate the mineral in its own way. Otherwise, if it is hydrothermal system, repeated hydrothermal activities should be there. And moreover, if it is a magnetic, high volatile content should be there. If it is a hydrothermal system, then activation, deactivation of shear zones or fault zone is very much required to redistribute the elements. Finally, the deformation metamorphism also plays very important role. Though sedimentary I have not listed here, but sedimentary deposits are equally important when we are dealing with the mineral system approach. And these 5 main important ingredients as well as these ones of factors depend upon their presentation and combination, different mineral system different one can perceive. Whether it is magnetic, sedimentary, or a magnetic hydrothermal, or a metamorphic hydrothermal, or it is a orogenic type of metamorphic system, or it is a purely sedimentary, basinal or analytical, or it is overtreated. Definitely overtreated. Only on a particular epithermal, after that some more type of things will come and overtreated. Once you know the mineral systems, then we can think about the critical minerals. Which mineral systems contain what type of treatment? That we call it mineral assemblages. If you know particular system, we know particular systems are generally associated with molybdenum, besides copper and gold. If you know resins and vein system, they are associated with all type of strategic mineral, tin, tungsten, lithium, iodine, platinum, all these things. If it is IOCG, it's a nickel, main is copper, iron, uranium, nickel, all multi-metal elements. If it is a DMS, FedEx, also it contains a lot of critical minerals. That's zinc time. First, we need to understand which type of system we are working on. Then, accordingly, what strategy should be started. We will explain this beautiful example of mineral system approach, how it has worked out in a real world examples. First, the tectonic activity is says generate heat and fluid. Why? In a subduction process, we generate heat as well as water fluids. As a result, you know that many phosphate deposits are associated with exclusively with phosphate system, whether it is Andean or it is or elsewhere in the body. But these all metals and metals are generated through this fluid. When this fluid comes up, so through this tectonic fluid, whether it is a fault or a shear zone or any elements, along that fluid has to come up between it above the between of transitions. Then the fluid can come from magnetic source, it can come from metamorphic depolarization, it can come from alkaline, it can do any matter. Okay. But if you interact, fluid of interaction is one of the most important one. That interact at different depth in the process. If we know the assemblage, gold and arsenic, maybe we are in high temperature, it is a high temperature assemblage. If we get tellurium associated with that, that means we are in moderate temperature gold. If we may this is cadmium and sometimes with CD. I think cadmium as well as antimony. Then we are in the surface zone where it requires very less temperature. So this fluid metal transfer, these metals they don't transfer in general as in solid form. They always prefer in a complex form, either in a chloride complex or in a hydrogen sulfide complex, sulfide and chloride complex. Here they interact with pentagraph. Different pentagraph. Different they change up your oxidation and reduction. They start cracking, they start precipitation. And generally, when they reach along the dilation zones and orthogonal structures, then those were called these both structures or above the antithetic faults. Then the pressure will release all of a sudden, fluid will boiling start place, metal will precipitate. Whether it is gold or it is a copper or any other metals they work in the same pattern. Only the process, what process it works, whether it is fluid mixing or a phase separation or any other process. But they ultimately, many of times we are in a grain stage happening, we are unable to see. Every time we are not getting out fluid fusion, but in form of alteration, as a geologist, you will get its footprint in the field. That is a very important thing. Now the exploration as well as the discovery, as well as our things, technology, how it has evolved from 1950 to 2020. Why around 1960, so many deposits were discovered. 1960, not only geophysical input, not only related to discovery, but also one of the best versatile chemical instrument that is called AS is introduced. And that time it was one of the best. And three are combined. And not many deposits were discovered. Not many deposits. Today, everything superficial has undergone. Now we are living 3D without drilling. We are jumping to 5D, AI and ML. But without subsurface 3D subsurface data, how a computer will interpret without sufficient data of your drilling? Without drilling information, it's virtually impossible to give any your probability to subsurface vectors. In ground field, this thing is very much important. If you have enough drilling data, then you can drilling data and will give whatever kind of you develop as for means your model that will give. But the drilling data is required. In this context, many people are working, only academic people, they cannot do these things. Without GSI is not possible. GSI and other organizations who are working with the subsurface are dimension. Without that dimension, deposit discovery is not that easy. You have to have third dimension data. Now this second part, I will come how classic example of this from a Western Craton will help you in Bundelkhand. It looks like a barren quartz, but in fact it's a barren. There is nothing on the surface. You will see it is a very white, milky white quartz mix. Even if you go there, great, you will not get anything except little bit some magnetic and peroxide there. Ferruginous states you will get. Otherwise, you won't get anything. And this is a small deposit, but very interesting. Now it is growing as a bigger deposit. I will give you how it became one private company has taken, and now they are developing like anything. I will discuss in detail. This is along the western margin of the Coastal Craton, and the northern shoulder of the Bundelkhand and the Craton boundary. In this part of the Craton, there are not many shear zones that develop, 4-5 shear zones that develop. Parallelly, they are parallel in the northwest direction, parallel to the boundary points. And these linear shear zones, they contain good amount of copper. Along this line, along the D, they change the assemblies. At places they are lead zinc, at places they are copper, at places they are garage. So I will explain why it is happening. When fluid is coming, the deeper fluid is copper, then subsequently zinc, subsequently lead, then ultimately lead is a garage. So in this area, zinc granite systems are working. How it is working, I will explain through the classic example in the form of a Craton diagrams. This is the Western Buster Craton where not many shear zones are here. Here I have worked since 2005 to 2010. I am working for last 20 years. I have been working in this part. Uh, these all yellows they are clustered or a deposit. And out of these yellow and here 4 or 5 have been oxide. Very good copper values are coming yellow in these shear zones. Sometimes they are red zones. Interestingly, the inside part, because of the barren, we are not touched it, we are left it. Only 2015, in the STM was serial 2030, right from the STM build 1 or 2 build, the report stage was launched. And in the field, when we were, I was not there during STM time, but it was from a previous workers who were working there. In the surface, you will get like this. So it is no footprint. But if you go very minutely with your presence, with the track energy structure, if you are lucky enough, you may get across the malachite type of staining. But these are not malachite. This is the where I sit and I opened my eyes. No. Because in this type of minerals I have seen along the canals and another canal shear zones, I have studied under microscope, they are protein, they are radium, and they are copper sulfates. If copper sulfate, that means right and high acidic environment we are working on. If high environment, there is a chance to get the other type of alteration, but it is very difficult at the time to say about mineralization. But to consider the idea of if you persistently you will look at the details, but you will get mineralization without any doubt. That is how when G4 was mounted, 2 borehole are drilled. That time I took transfer from Shillong to Nagpur. I joined. Then it explains me what even 80 meter into vertical 60 meter depth oxidation zone is continuing. Then can be many reasons why oxidation is why can't. Even if you get up to 100 meter depth, depend upon your groundwater oxidation and other factors. It bothered me. When 700 meter is drilling assignment is given, if we will continue this way, then we may lose the technology. So that what is my experience of this type. So I have not worked here, but only there were 60, 70 kilometers above this year, I worked slowly. So three things come to my mind. Why oxidation will continue up to 60 meter vertical depth? Is mineralization continuing with oxidation zone? This false signal system and need a fast tested to concept oriented mineral system model. And this type of things is required for molecular pattern. So there is no doubt about it. Artificial pattern diagrams. Around the vertical zone, oxidation is coming. When if it is a false signature, then we may not get. If it is a as per the concept, if it is bottom, then very less represented in this way. So down below the oxidation zone. So we tested, but as we know, we are doing against the SOP of G2, G2, G3, UNFC guidelines, but nobody was including the PTSI, was sharing this session, I was presenting during NPR, but I convinced, no. Utility here we have to go very unorthodox way. Then we will get otherwise. It is there, because it is there. Because all other things we are getting. Definitely we will get, but it's very difficult. I convinced one borrows. Because of my current experience, I convinced to intersect at 7 meters upon 6.5%, at places is 2%, at places is less than that. But it is continuous zone. Then it opened our eye. Yes, in this area, 16 zone is very deep. We need to go beyond that. Then we will get. Then somehow we manage another code will that is increasing. 5 meter zone, more than 1%, even if up to 6% in a particular 2 or 3 samples in your plant. This is a virtually a current working on this structure. It is what I am talking about 150 meters, 150 implant depth. 150, then you can calculate the second level. But if we see the oxidation zone, then if we leave, then how will we discover the difference? It's not like that. Because I convinced them, 2015, when I published my first article, I read a lot of literature, I understand the ultrasound systems, how ultrasound being worked out. Here, look, there is no chloride, only on the surface part, built to what weight. But when we build, we got not many things as expenses. Then at 127 meter depth, very beautiful this epithermal type lamellar textures, they are building chevron textures, overload textures, whatnot. All type of style patterns, way Tong et al. Even in economic geology paper, epithermal type of texture. The more important is that because of basic environment here down below, this was about the photo which led to the discovery. Because of this rotation fact, it only occurs in high acidic environment, in highly oxidized system. And you can expect that when high sulfur content is in the system, then only this type of things in form of recess you will get in the field. These are the field levels. I believe in field levels because these are the things where you have to think. Then based on this, though it was developed in the COVID time, I couldn't publish this year. It was published. Rare reservation of epithermal type of property project in the Massachusetts art magnetic system. Here, very interesting. This area, what happened? It is a pair of volcanic art. Sorry, it is a pair of your volcanic and plutonic examples. Volcanic part is eroded, very thin layer eroded. Generally, epithermal deposits when we are talking about, they all are associated in generally volcanic environment. But here it is volcanic environment is not there. It is eroded. The second part, the tectonic part, the plutonic part is preserved because of some tectonic reasons. We are working to understand. These are the things where we put the two different domains. Otherwise, had we completed the sun level 70 meter, 60 meter, as for the first level G4 investigation, we could have not encountered this. And the more interesting is when we take petrology, it has been two messages. Copper part, one system. Totally, in an injury, it is totally different. There is no barrier there is no light there, no zinc there. But when we are working in a sympathetic, another fault, another CO2 parallel 7 kilometers from there, where zinc is working, zinc and lead. That means different fluid system are working in the system. We carry out fluid fusion study in great details. Fluid fusion salinity, white contrast, no salinity is relative blood rate, white salinity because of magnetic fluid as well as mixed fluid. And when we carried out fluid thermometer, then ultimately carried out some price. Some price also in two clusters. One is showing the influx of your sedimentary injection sediment, other is your purely magnetic in and around two primary values of sulfur delta 34. Then we consider these things that if this is the things, lot of copper we are getting. I will come to this first. I will discuss this. Now, as on dates, this was option. Around 1 point something million copper deposits were given at point 59 cut of something, but it is purely constant deposit. That's why our team officers they were awarded geoscience award for constant. It is purely constant. But today, what we consider 2017 because that 700 vertical depth, you see, at 500 vertical depth, around 650 or 700 meter depth, we are getting same copper mineralization, same type. Whether gold will be increasing along this type, across this type, we are getting different zones. I discussed with whom I can sometimes have taken my opinions. I am not giving anything, only whatever is coming, because it's a geoscience discovery. Geoscience given the block option government. So I need to help in that area. Now, 11,000 meters they have two very good minerals in that region. Another 22,000 they have up to 2 it. This is how you have to take this. When we start up with 400 meters, so what do we do? Well, you have to take this with no other things. You have to risk, do not you get. When quantity is so thick, you have to intersect the equal side also. Only you are still in the animal side. Then why you are stopping your body? Then you won't get anything. You have to go. When they intersected with anyone side, they got very good mineralization. But by the time they reach more than 600. That is how you have to take this. Bundelkhand Craton also, we need to deal in a separate way. Okay. anyhow, I will come to later that. Yes, we consider in a field you will get like that, parallel parts here and there. I see poorly exposed rocks in the system. You will frustrated while you will work. Only cultivated land, cultivated land, cultivated land. You will not see any rock exposure. Whenever you will see, there will be some part resistance like some mounds, something like that. If that is there, that is another some place. That is some parts of parallel to the other place. But here, when we are going, getting down and down, now potassic ultrasonic is appearing. That means something else. When potassic ultrasonic is coming, in now up to that depth only we are getting chloride, at places it is coming potassic ultrasonic. Now the quickly potassic ultrasonic is coming. Now vanadate has entered in the system. Now we are working on how it is working there, and we will work out. Now coming to the third part, that is about the Bundelkhand Craton, which is one of the oldest pattern in our country, like your Burma, Sindhu, Bastar, and your Arabic pattern. But compared to other pattern, extensively it is also worked for other purpose. But minerals in India, many people have worked for quite long times. From Basu Saab, since Basu Saab was the one of the pioneer worker in GSI, who has worked in Bundelkhand Craton, followed by so many GSI, NR people, Rosa, from AAP people, from SIA. Many people give us mark there. So many SPCs are, I can't number of. But then what went wrong? Why we are not getting minerals? But as a person, I believe in field. I am not working in field. Honestly, I say, I cannot comment much on this. But once I attempted, but I couldn't get succeed to mount an item. But we will get mineralization. As an expert and geologist, I strongly believe. But what way we should approach? That is the most important. Well, we should revisit. There is no doubt. The country is granite, very low in limestone beds. That means mental input is very weak. Mental input is very weak. So mental input is not there. Then there is still I can't say that it may be less explore. We need to go at maximum risk, deeper boron. We have to put boron, deeper boron, and what all parts going, right parts going, may not be mineralized. One or two you go with because not only with what they my experience in Methodata when I met there are 28 they are currently offering this number systems. 19 bands they there are only one band is containing mineralization. Then that only gives me the idea why 19 bands there and why it is only mineralized. That is how you work out, start with one with the geophysics. Now GSI has a MOU with NGRL, DSI survey they are doing, MP survey they are doing, and in the northern transit, we start from Churu to Pitambur, which will come cut right along the heart of your Bundelkhand Craton. It will give you the exact picture. So MP survey was carried out in Bundelkhand Craton 2013 by Gokran et al. But that was for different purpose. Unless purposefully for understanding methodology, for understanding the resistance, understanding conductive zones, we will not work out, which followed by geophysical work we will not get. And more important, geophysical point of view, we should approach the things the way Australian people will succeed in Indian pattern. Indian pattern, there are only few gold deposits. What about the other part? They succeed with Gwalior pattern as well as Indian pattern using Kingston. What is Kingston? Corporate index mineral system. This is also again quite from your tools. Things like mineral indicator system. We don't care this mineral influence to the manufacturer. Everyone is working on a mineral scale, nano scale. We need to go up to that scale. What is going to be linear, what is going to be map, what is going to be studied under technology, what is studied under CL, studied under chemistry. Why was simple green not help? Then we want to go up to grain scale, crystal chemistry scale. Then I think we need to assess in this way only. Moreover, any presently you need to see any quad textures are there on surface or not. If that will be there, then our will see. Only you may get some quad textures, some textures when it is against boundary. Simple zones where some fluid rock interaction has taken place. Or another sedimentary basin when the fluid rock interaction taken place there are. Otherwise, it is very difficult. Quad is there. Elsewhere we visit in the quad because quad is a great mineralization. In this Bundelkhand Craton, wherever you go, you get quartz, but no mineralization. That means what is really there, while not mineralization. If the mineralization part is denoted, one mineralization part still there inside at a crater. That means that this enigma has to be sorted out with multidisciplinary approach. There could ultimately be AIM, that may be. But suddenly if you jump AIM, it is not everything that will give the target point for putting a board. It needs to very concept knowledge. Many people have worked here, many areas are publicly available for in the public domain, but ultimately geologists who is working on this field, we need to develop these multidisciplinary skill, integrate techniques, and construct a model, then higher accurate is to some state maximum risk. I don't think they are going to miss. First, we need to discover the things, then the mineral system we have discovered. Whether it is a popular system or it is a ice system. Yeah. Then, if we are getting good amount of like 500 return, then why not in the Bundelkhand Craton? Where we are getting the signature in England. Then what went wrong? Why so far we are not reported pipes within Craton? Because of only three Craton getting or anything else. That also will give the idea about the magma systems, how not only about the only internet levels, but about the internet system also. Normally, if we work out both way, then I think this way or that way, one day we will come to discover two minds. This is make this is only if I ask and if I had been with you only I take this. There is no other one. I have to convince the higher to the boards. But when you connect to the boards, you have to work out a model. You have to convince by showing that this is the field address model, this is the petrographic things, this is the how field chemistry says, this is how chemistry says, this is how institute chemistry says. Then we should test it at least one or two places. One places may mislead, but two, three places to test. At least one will come with us. System. They are putting investment in 7, 8 places. They are in one place. Like that only will take this. This is all I know. This is very my thought. Whether I don't know how much I have done because I have not worked very physically there, so it's very difficult. If you approach mineral system approach, if anything is there, it is going to miss because it gives right from its source, the main where it comes from either upper metal or lower source. Still, the surface where you are working. That is the place where you are seeing now. This center is preserved. This center is preserved, so you need to establish it in a form sequence, in a experiment sequence. You may not get like a stratigraphy segment like a sequence. Then you need to rebuild it, and rebuild and remodel it. Then what are the necessary here, what are the available here. Then what thing, then we need to bring hyperstructural into place, to carry out the ultrasound studies. Then, like this, I think Project Antobar, they have done some good job in the aerosol part, but this is the thicker part that your Bundelkhand Craton. Once they will do 20 survey, the safe rooms, then really it will come. This is all about. I acknowledge extremely geological surrounding extremely heartfelt thanks because of this what now I am able to continue explaining. Mr. Mines is encouraging, day and night is encouraging to carry out my research. I am lucky to get both projects from both departments and I am carrying out my research but different commodity, but both are critical but different commodity. And my now as I acknowledge, this is all about any point, any comment, any things, most welcome, whatever little I am willing to share it. Now, I am always available for JSA geologist at any time for any type of query. Please mail me and if I know, I will solve it.
Thank you. Thank you so much, sir. Now the session is open for discussion. Anyone?
This one?
Yes. Yes, sir, you can. Mic. Please provide mic.
Can I speak? Ma'am, am I audible? Can I speak?
Yes, sir. If someone want to speak in virtual mode, you are most welcome.
Yes, and if not spoken, I would like to point out something to Professor.
Yes, sir.
Am I audible? Go ahead, sir.
Yes, yes, you are audible.
Happy congratulations on your discovery of that because
Hello, hello.
what I would like to point out is, we are talking about the systems and the system. So, is a source in the nervous system and the nervous system of comorbidity. Earlier, it was not economic to extract this comorbidity from the diet, but at the current prices of around $55 per ton of this comorbidity, it is economical to extract the comorbidity from the diet. And diet is normally a major constituent as compared to the phytoplankton or the sunlight. So, I mean, this is a focus discussing the focus area in the study in the system also. And the overworking diseases of water from the diet. May I reply that? Yeah, please. Thank you for your good question. Pyrite generally contain nickel cobalt, but all pyrite generally they don't contain nickel cobalt. Pyrite is a necessarily same. All that because that is very different. Sir, think that those fluid has come from some sedimentary source. Then cobalt will be increased in a pyrite. If has come from a magnetic ultramafic source, something random source, those pyrites are then only sir. Usually sir, you won't get both. Either you will get cobalt or you will get nickel. Then moreover, you only one can only understand why they do this type of analysis mathematics. If you get 500, I don't know after extraction how much in a during beneficiation process how much investment can taken place